In a stunning and unprecedented revelation, scientists have announced the discovery of a planetary body that could transform our understanding of the cosmos. NASA, long known for its groundbreaking missions and discoveries, revealed that this celestial object is extraordinary not only for its size or position within the solar system but for the unusual light patterns observed on its surface. These patterns, in some images, appear almost artificial, sparking curiosity and debate among scientists and enthusiasts alike. While the scientific community approaches such claims with cautious skepticism, the evidence is compelling enough to demand attention. Could these lights be the first hints of alien technology, or are they the result of a natural process so rare and unfamiliar that they seem engineered to our eyes? To understand this phenomenon, we turn to one of NASA's most remarkable missions, the Dawn spacecraft, launched in 2007. Its purpose was to study two of the largest bodies in the asteroid belt, Vesta and Ceres, unlocking secrets from the earliest days of our solar system. Dawn's journey would eventually reveal something no one expected: mysterious glowing lights on the surface of the dwarf planet Ceres. Dawn was equipped with a revolutionary ion propulsion system, allowing it to travel farther and maneuver more efficiently than traditional chemical rockets. After a successful 14-month orbit around Vesta, during which it captured stunning high-resolution images of craters, ridges, and ancient terrain shaped over billions of years, Dawn began the next leg of its journey, toward Ceres, the largest object in the asteroid belt. Ceres has a long and fascinating history. Discovered in 1801 by Italian astronomer Giuseppe Piazzi, it was initially classified as a planet before being redefined as an asteroid and finally as a dwarf planet in 2006. It remains the only dwarf planet located within the inner solar system. With a diameter of roughly 950 kilometers, or 590 miles, Ceres is massive enough to be nearly spherical and contains more than a quarter of the total mass of the asteroid belt. Despite its proximity, it remained largely unexplored until Dawn's arrival in early 2015. As Dawn approached, increasingly detailed images of Ceres' surface began to stream back to Earth. What had once appeared as a tiny, blurry speck through telescopes was now revealed as a rugged, cratered world. Yet amid the dark, rocky terrain, something extraordinary immediately caught scientists' attention: bright, glowing spots, particularly concentrated within a massive impact crater known as a crater. These spots reflected sunlight with such intensity that they seemed almost artificial, like mysterious beacons on an otherwise desolate landscape. Initial theories varied widely. Some scientists proposed that the lights were patches of ice reflecting sunlight. Others suggested the presence of metallic minerals or unusual chemical compositions. Some, more cautious, warned that unusual lighting conditions could create optical illusions. However, as Dawn moved closer and its imaging resolution improved, the mystery deepened. These bright spots were real, persistent, and composed of highly reflective material. Further analysis revealed that they were rich in sodium carbonate, a type of salt commonly associated with briny water. This indicated a remarkable possibility: liquid water, or at least briny slush, might have once reached the surface and, in some areas, could still persist underground. The bright deposits hinted at a type of cryovolcanism, a rare geological phenomenon in which instead of molten rock, volatile materials such as water, salts, ammonia, and other compounds are expelled from a planet or dwarf planet. Cryovolcanism is extremely rare, observed only on a few solar system bodies, including Saturn's moon Enceladus and Neptune's moon Triton. On Ceres, the largest bright region within a crater, called Spot 5, revealed a central dome surrounded by cracks and salt deposits, strong evidence of a potential cryovolcano. Dawn also detected faint, mist-like hazes rising from the crater at certain times of day, suggesting ongoing sublimation of volatile materials from underground sources. This implies that Ceres may still be geologically active, an extraordinary revelation considering that most small bodies in the solar system have long since cooled and become geologically inert. How could such a small object retain enough heat to drive cryovolcanic activity billions of years after its formation? The answer lies in its composition and history. Ceres contains large amounts of water ice, hydrated minerals, and carbonates. Ammonia-bearing clays suggest that Ceres may have formed farther from the Sun and migrated inward, and ammonia acts as an antifreeze, lowering the freezing point of briny water. Geophysicists now hypothesize that Ceres has a layered interior, a rocky core surrounded by a muddy, icy mantle. Brine pockets within this mantle could periodically rise to the surface through fractures, especially after impact events. Once exposed, these brines rapidly sublimate, leaving behind the reflective salt deposits observed by dawn. These findings have profound implications. Ceres is not just a dead, rocky world, it may harbor conditions suitable for microbial life. On Earth, extremophiles thrive in environments previously thought uninhabitable, including subglacial lakes, deep ocean brines, and acidic hot springs. If life could exist in such extreme conditions here, it is plausible that hidden reservoirs beneath Ceres' surface might host, or may have once hosted, microbial life. The discovery challenges long-held assumptions about where life might arise in the solar system. For decades, scientists assumed Earth-like planets with oceans and atmospheres would be the primary candidates. Now, icy moons and dwarf planets with subsurface oceans and ongoing geological activity have entered the spotlight. Ceres' continued cryovolcanism demonstrates that planetary evolution is far more complex than previously believed, expanding our understanding of how solar systems develop and maintain diverse environments. And what of those mysterious, seemingly artificial lights? While the scientific consensus is that they are naturally occurring salt deposits, their optical appearance, bright, glowing, and almost engineered in nature, continues to captivate both researchers and the public. It is a powerful reminder that nature, in its complexity, can produce phenomena that mimic the work of intelligent design. When the Dawn mission concluded in 2018, the spacecraft exhausted its fuel and was left in a stable orbit around Ceres, effectively becoming a silent sentinel. Yet the data it collected will continue to be studied for decades, revealing secrets about the dwarf planet's geology, chemistry, and potential for life. Today, Ceres remains one of the most enigmatic objects in our solar system. A dwarf planet with bright lights, underground oceans, and tantalizing possibilities for biology. Whether or not we ever detect signs of life, Ceres demonstrates that the boundary between a lifeless rock and a living world is far thinner than once imagined. At Discovery at 2.0, we will continue to follow such cosmic mysteries. Every light in the darkness could be a clue. Every anomaly might be a revelation. With each new mission, we inch closer to answering the ultimate question. Are we alone in the universe? Ceres has shown us that even the smallest worlds can hold vast surprises, and the cosmos is filled with wonders that challenge everything we think we know. The story of Dawn and Ceres is a reminder that exploration is never complete, and every discovery reshapes our understanding of the universe and our place within it.